All right, guys, hey, today is our last section of Chapter 3, which means next class we will review, which is going to be Monday for you guys, and then on Wednesday we'll take the test. Okay? So today, it's 3.5, we're talking about equations, writing equations of parallel and perpendicular lines. We've been talking about parallel and perpendicular lines here recently. Our objectives today are to identify parallel and perpendicular, and what do those exactly mean? To write equations of parallel and perpendicular lines, and then to use this thing called slope, which hopefully we've heard about, to find the distance from a point to a line. That got left out, didn't it? So we're not going to do the last one. You can omit that last one. First of all, what's slope?
Is it rise of a run?
I think that's our best way of remembering what slope is, and that's usually the thing. Slope means the rise over the run. Now, what does rise mean?
How many lines it's going up?
How much we're going up and down. Now, which variable, or x or y, goes up and down? Y does, right? So sometimes we'll call this our change in y, or delta y. That little triangle is a Greek letter delta. Okay? I usually just say the change in y over the change in x. So the rise talks about how much we're changing up and down, and the run talks about how much we're going left or right. Okay, so the slope of parallel lines. Okay? In a coordinate plane, two distinct non-vertical, I was going to underline it, but I underlined it for me, non-vertical lines are parallel if they have the same slope. So if two lines are going to be parallel to each other, they're actually going to have the exact same slope, which is the exact same rise over run. Okay, here we go. Example 1 here, or I guess this first part. It says, hey, find the slope of line 1. Now, if we're given the line, guys, here's what we're going to do. We're going to go over to the line, and I'm going to find a point where it crosses, I don't know, that one. I think there's many of them. It crosses that point exactly. Okay? And from here, I'm going to go up 1 and over 1. Up 1, over 1, up 1, over 1, up 1, over 1. So my slope is, my rise is how many? 1. My run is 1, which that means my slope is 1. Okay? If I go to line 2 again, I'm going to find a point where the graph crosses exactly, and there are many here. So if I just do that one, well, I'm going to rise 1, run 1, rise 1, run 1, rise 1, run. That's pretty hard. Everyone say that 7 times fast, as fast as you can. Ready, go. Gotcha. So the rise is 1, the run is 1, which means my slope is 1. So are these lines parallel? They are, in fact, because they have the same slope. Okay? Okay, here we go. Slopes of perpendicular lines in a coordinate plane, two non-vertical. What's non-vertical mean? Vertical means up and down. So basically, any two lines that aren't going up and down, we'll talk about that here in a bit, are perpendicular run out of room there, if and only if the product of their slopes is -1. Talk about that here in a second. The products of their slope is -1. Okay, what is the slope of line 1? Well, I'm going to find a point where it crosses exactly. How about that one? And the slope there is, my rise is 2, my run is 1. My rise is 2, my run is 1. So therefore, my slope is going to be 2 over 1. And anything over 2 is, anything over 1 is just that number, right? So the slope of line 1 is 2. Have I confused anybody yet? No. Cool, awesome. Slope of line 2, well, if I pick this point, I'm going to go, instead of going up now, I'm going to go down, aren't I? I'm going to go down how many?
1.
Well, I'm going to pick 2 points. How about that point and that point?
Yeah.
I'm going to go down 1 over 2. Now, I'm just going to, what if I picked that point and this point? Well, I'm going to go down 2 over 4. So the first two I picked, I went down 1 over 2. What? Oh, it's negative, right? So if we go down, the slope is negative. Now, a way you can check yourself, if the line is going uphill from left to right, like a hill, it's positive. If it's going downhill, well, then it's negative. So this needs to be negative 1/2. Now, I just want to let you know that if I did negative 2 over 4, well, what does that reduce to? Negative 1/2. So you can get the same answer either way. So our slope of line 1 is 2, and the slope of line 2 is negative 1/2. Now check this out. If we multiply them together, 2 times negative 1/2. First of all, what's a positive number times a negative number? Negative. It's always going to be negative, isn't it? And what is 2 times 1/2? What's half of 2? 1. It's just 1. So here the slope is, in fact, negative 1. And that is what tells us lines are perpendicular. Are these perpendicular? Yeah, they are. Okay, now let's dive into this a little. What do you guys notice about the slopes of the lines that are perpendicular? What do you guys notice between 2 and negative 1/2?
One is positive and one is negative.
Okay, one's positive, one's negative. Aaron?
They're one's the reverse of the other.
I like the opposite.
Okay, you said reverse. I heard Austin say, what did you say before?
Reverse of each other.
Reverse. You guys heard of the cha-cha slide? Reverse, reverse. That's what made me think of that. I'm sorry. Yes, reverse. There's another math term for that. Ellie, do you know it? Reciprocal. Repeat after me. Reciprocal. That means we're going to flip our fraction. The thing that's on the top goes to the bottom, and the bottom goes to the top. Okay? So, yes, they are opposites, meaning negative and positive. We'll call that opposites, and they are reciprocal. So here it says the mathematical terminology for this is opposite reciprocal. So perpendicular lines have opposite reciprocal slopes. Again, opposite meaning opposite sign. If it's positive, it's negative. If it's negative, it's positive. And reciprocal means the fraction's going to be flipped. Okay, so here it says line A has a slope of 3, and line B is parallel. So we've got 3 lines here, line A, line B, and line C. So if line A has a slope of 3 and line B is parallel, what's the slope of line B?
3.
3, because we know that parallel lines have the exact same slope. Okay, and if line A is has a slope of 3 again, but C is perpendicular, what's the slope there going to be?
Negative 1/3.
Negative 1/3, because we need to include that sign change. We're going to do another one there. You guys can just watch this if you want. Well, let's say line A had a slope of, let's say it's negative 5/3. Okay, and line A and B are parallel, so what's the slope of line B going to be?
Negative 5/3.
Negative 5/3. And A and C are perpendicular.
3 over 5.
Positive, since this is negative, it's going to be positive 3/5. Questions, comments, concerns?
No.
Okay, you guys seem to be doing okay here. All right, now we're going to get this cranked up a little bit. I'm going to go right here, and we talked earlier about how slope is the rise over the run. I want you to write this down again, because it's that important. Okay, and the rise we talked about being the change in our y variable over the change in our x variable. Now, anyone remember what the formula for slope is? We talked about rise over run, but actual, the formula. Aaron, do you remember? Okay, I'm going to stop. Keishan said y equals mx plus b. That's slope-intercept form of a line. Okay, but I want the formula to calculate slope. That's what you're going to say, Aaron? Keaton, you remember?
Y minus x over
Not quite. You're close. Devin, you remember it? Jake, algebra 2? Oh boy. y2 minus y1. We're going to change our y. So what we're going to do is we're going to subtract them and say, hey, how much is our y's changing? Over x2 minus x1. Keaton, is that what you said?
Not like, I said y minus y over x minus x.
I thought you, okay. You said, yeah, you said y over y minus x over. So you're close, but not exactly. Okay, so here's the deal. If we're given two coordinates on a line, we know they're coordinate points, we can calculate the slope. Now some people say, hey, Mr. Cole, why can't we just use the graph here and do rise over run like we did before? Well, that always won't be given to you. So you won't always have the graph to do that. In this problem, we do. We do, but that won't always be the case, okay? So if I'm looking at line A, which is the blue one here, I'm given 2 points. I'm given -3, 2, and I'm given 0, 3. And here's what I want to do. I want to label one point as point 1 and one point as point 2. Why do I want to do that? Well, when we're beginning, we need to understand which is x1 and which is x2. So here's what this means. This first coordinate, this first point, this is x1 and that's y1 because it's the first point. This is x2 and that's y2 because it's the second point. So if I plug this into my formula, and I'm actually going to write this out here, y2 minus y1, I'm going to write kind of small x2 minus x1. What's y2 here, Brayton? 3. That's the y coordinate of our second point. So y2 minus y1. Alex, what's y1? So we're looking at, we're looking at this point and this point.
Oh. 0.
Not 0.
Or 3.
Not 3. This is our y coordinate of our second point.
Oh.
This is our y coordinate of our first point. So 3 minus 2. Now we go to our x's. Now it's important to understand we used 3 first, so I better use 0 first. So it's going to be 0 minus x1, which is -3. Now, minusing a -3, that's like what?
Adding.
That's like adding. So here we go. I believe our slope's going to be 1/3. Now again, we can check ourselves because the pictures that are given to us, the slope is going to be rise 1 over 3. That makes sense. Any questions about how we use this slope formula there? Okay, now I'm going to go to the blue line. Excuse me, the red line. Now the red line, I've got 2 points. I've got that point and that point. I'm going to call this point 1 and that point 2. Just to let you know, it doesn't matter which one you call point 1 and which one you call point 2. So I'm going to write the formula out again. y2 minus y1 over x2 minus x1. Guys, from my experience, you write the formula out, you're more likely to get the problem right. Well, what do I know? I'm just a stupid math teacher, right, Austin? Okay, here we go. So y2 is going to be what? You say it? What does? 0. So it's going to be 0 minus y1, which is, Pierce? -1, so we're going to be minusing a -1, which is plus. And then we're going to go to our x's. So x2 is 2 minus x1, which is 0, right? So here the slope is 1 over 2. Now again, we can go to our picture and say, hey, I'm going to rise 1 and run 2. Okay, that makes sense. Whoa, what the heck happened? Find the slope of line, let's see here. Let's just do C right now. Go, find out the slope of line C. Okay, line C. Courtney, what'd you get for the slope?
I got 1/2.
Do we agree with Courtney with slope of 1/2? What's that tell us about line B and line C? They're parallel, aren't they? They've got the same slope. Now let's look at line D, which is the purple one. Now, do we have 2 points on that line?
Yeah. Yes.
I only see one in purple though.
The other one's on the blue one.
Oh, this line is on both lines, or this point, excuse me, is on both lines, so we can deal with both of those there. So if I count this as point 1 and that as point 2, I'm going to write my formula out, y2 minus y1 over x2 minus x1. I'm going to do this kind of quick. I'm going to do 0 minus 2, and then I'm going to do negative 2 minus a negative 3. Minusing a negative is plus. So my answer then is going to be, what here, negative 2 over positive 1. So here are my 4 slopes of those lines. Now, what do we notice about, or what's this tell us about lines B and line D?
Oh, they're perpendicular.
Her lines B and line D perpendicular because their slopes are opposite reciprocals. Questions there? Okay, so by finding slopes of lines, we can determine if things are parallel, perpendicular, or potentially neither. Shane, question?
Okay, so let's. Wait, never mind.
Austin, question?
I was just gonna say line B and C are parallel.
Yeah, I think we already said that, maybe. We said that before. But you're right, they are parallel. Okay, now we're going to be talking about writing equations. I think slope, that's relatively new. I don't believe that we've seen this. You might have seen it in Algebra 1, but it's always a good refresher. So this is important to us. This is point slope form. Okay? It is another way to write an equation of a line. Okay? So here's the example. It says write an equation of a line passing through the point negative 1, 1. So it's going to go through that point, and it's going to have a slope, in that it is parallel to that line. It's going to go through the point negative 1, 1, and it's going to be parallel to that line. Now, if it's going to be parallel to this line, what does the slope have to be? The same slope. What's the slope of this line?
2.
It's 2. Remember, this is in slope-intercept form, so y equals mx plus b. Raise your hand if you remember that.
Yes.
If you don't have your hand in here, I'm going to call Mr. Ham. He's going to come down there, hit you over the head with a notebook. Okay? mx plus b. Our m is our slope. Okay, so our slope for this line is 2. So what does the slope of this line have to be? 2. So I'm going to put a 2 here. Okay, now, x1 and y1, okay, they represent the coordinates of the point that we're going to use. So, I'll go with y1. y1, what's the y coordinate of this point? It's 1. So I'm going to plug in 1 here. And what's x1?
1.
Negative 1. Okay, so here's what I'm going to do. I'm going to plug in, okay, and I'm going to stop here for a second. Let's just graph this line just for a quick second here. What's my y-intercept?
Negative 3.
Negative 3, so I go down to 3, right? And then my slope is 2, so I'm going to go up 2 over 1, up 2 over 1, up 2 over 1, and there I've got this line. So what I'm doing is writing an equation of the line that goes through the point, negative 1, 1, and is parallel to that line. All right? Now, here's what we're going to do. We're going to use point slope form. You guys need to memorize that. Can't give it to you. You'll use it this year. You'll use it next year in Algebra 2. If you take pre-calc, you use it in pre-calc. And if you take calculus, you use it in calculus. Okay? You'll use that all the way through your math career. So what I like to do is write it down every time. Y minus y1 equals m times x minus x1. So I'm going to plug in the information. What's my slope?
2.
2. And x. Now here's the kind of the tricky part. You guys notice how there are negatives in the formula? So we need, this needs to be x minus 1. Excuse me, I apologize. Our x is negative 1, isn't it? So minus the negative becomes plus. So there's minuses in the formula. Okay, so if it's positive, it's negative, it's negative, it's positive, if you comprehend that. Now over here, it's going to be y. Now my y is here, so that's positive, so minus 1. Now that doesn't really help us a whole lot, does it? I want to get that. I want to get y by itself here. So how do I get this? How do I get y by itself? Before we add 1, let's distribute the 2. So I'm going to have y minus 1 on the left equals 2x plus 2. And then we can go ahead and add the 1 over. And I get y equals 2x plus 3. Oh crap, isn't this the same answer we had before?
No, it's positive.
Oh, it's plus 3. That means the y-intercept, instead of being at negative 3, is going to be at positive 3. So 2x right here. My slope is 2. My slope is 2. So that is what the line of the equation that we just had right here looks like. That's what the line looks like. Okay? Now, you don't need to graph it. That's not what we did that to prove it, but here's our work. To draw a line, write an equation of a line that goes through the point negative 1, 1, okay? And is parallel to that line. That's what we need to do.
Question.
Yeah.
So let's write an equation of the line passing through a point negative 1, 1. So shouldn't it go through that point?
Negative 1, 1. Does it? Does it go through negative 1, 1? Where's negative 1, 1 at?
Further down.
At the bottom right.
Negative 1. Negative 1 goes left, right? In 1, it's right there. Did it go through there?
No, never mind.
It should. I'm just not being very accurate. Does that make sense?
No.
No. Does it?
Yeah.
Yeah, it does.
Sure, whatever.
Isn't this negative 1, 1, Hannes?
Yeah.
Yeah. You were thinking it was a different point?
Yeah, I thought it was a different point.
Okay. Here we go. Example 3. Hang with me here. I know I'm talking a while. Write an equation of a line that passes through the point 2, 3 that is perpendicular to this line. Now, is this line in slope-intercept form? It's not. What do we call that? Anyone remember? Starts with an S. Ends in standard form. Okay, that is standard form. We want to get it into slope-intercept form. Kaylin, how do I get that into slope-intercept form? Kaylin, thank you.
Wait, oh no, it's y equals the next b. So you just move 2x to that.
Great. We're going to minus 2x on both sides. So I'm going to get y equals negative 2x plus 2. Guys, if it's in standard form, it doesn't tell us what our slope is. We need to get it into slope-intercept form in order to do that. So now, here's the slope of this line. Now, we want to write an equation that is perpendicular to this line. So this slope is negative 2. So if this has a slope of negative 2, we need to have a slope of what? Well, opposite reciprocal, perpendicular.
1 over 2.
Well, opposite means it's going to be positive. Reciprocal means it's going to be 1 over 2. So we're going to use 1/2 as our slope. Is everyone okay with how I got that slope? Found the slope of the line by getting into slope-intercept form. It says it's perpendicular, opposite reciprocal. Right, Austin? Yeah. Any questions there? Okay, now we're going to use point slope form again. So y minus y1 equals m times x minus x1. So my slope is positive 1/2. My x coordinate is what?
2.
So that's going to be x plus 2 or minus 2? Minus 2. And this is going to be y minus 3. So I'm going to distribute the 1/2 and get 1/2 x minus 1. And then what do I need to do? Add 3, right? So y equals 1/2 x plus 2. Now, guys, just to check myself here, let's graph this first one for a second. We're going to graph this just to make sure. It's going to be, what's my y-intercept there, Lexi? My y-intercept of this line? Of this line?
Oh, that one.
My y-intercept
It's 2.
is 2. I'm going to go up 2 units. Okay? And then my slope is -2, so I'm going to go down 2 and then to the right. Guys, I always work to the right, but I'm going to go up or down depending on whether it's positive or negative. So my line should look something like that. And then if I do this line, my y-intercept again is 2, but now my slope is positive 1/2. So I'm going to go up 1 over 2. My line looks something like that. Now, do those look perpendicular? Yeah, relatively close, don't they? Questions there at all?
No.
Okay, and guys, I'm actually going to skip the last one.